We are the Southwest Center of Occupational Environmental Health. We are with the UT School of Public Health. Here's our agenda. Right now we're doing the welcome and overview. Our first presenter will be Dr. Maberti, and she's the Senior Exposure Scientist at ExxonMobil. We will have a 5-minute break. Then we will get into our second presenter, Alex Cardone. He's the Industrial Hygiene Supervisor for the Department of Defense. Then we will have another 5-minute break, and then we will have our final panelist, Jorge Gomez, who is a Compliance Assistant Specialist with OSHA. Thank you to all the agenda producers, guest speakers, and thank you, our participants. Thank you, Jan Cohn, for helping us get speakers for this presentation. A little bit about us. We are a NIOSH Education and Research Center. We have training programs on industrial hygiene, occupational environmental medicine, occupational epidemiology, and total worker health. We also do a lot of outreach and continuing education on each of those 4 areas, and we do research or practice as well, including our pilot projects research training program. Save the date. So one of our next events is a webinar called Beat the Heat, how to help protect your patients from heat illness in the Texas summer, and that will be July 12, 2023. Our next IH seminar series will be September 7th. Some of you may have known a few months ago, we sent out a survey to our regular attendees, just asking them how often they would like this seminar series and what topics they are of interest to them. So you spoke and we listened, and many of you wished for it to go back to the schedule it was pre-COVID. So we're hoping to get it back on the schedule of every other month. So the next one will be September 7th, and it'll be a topic of physical and environmental. Please visit us at SWCOEH.org to get more information on our events. And here we are on social media if you wish to follow us. We're on Facebook, Twitter, and LinkedIn. So next, I will hand it over to our first presenter, Dr. Maberti. Silvia Maberti is a graduate of the UT Houston School of Public Health. Currently, she's a senior exposure scientist at ExxonMobil Biomedical Sciences, where she has worked in a variety of projects, including occupational, community, and consumer exposure modeling, as well as supporting the organization on regulatory compliance. She has been actively engaged in the TSCA risk evaluation methodology development, particularly related to occupational exposure and assessments. So please welcome Dr. Maberti.
Thank you, Serena. And somehow I cannot present again. So while I'm getting the connection back on, I wanted to thank you all for inviting me and for listening to this presentation. I think this is very important that the industrial hygienists understand what are the changes that are coming or the potential impacts that are coming to our profession, given the fact that EPA is now carrying out risk evaluations under the modified Lautenberg, or the, not modified, it's updated Lautenberg Chemical Substances Control Act. And I'm going to try to share it again. Now it's allowing me to share. Great. Hopefully you can see my presentation now. Okay. So as before we go into the implications, let me see. Okay, I wanted to provide some background on TSCA. I don't know about most of you in the IH profession, but to me, when I was working in the manufacturing organization, anything that said EPA and anything that said TSCA went straight to environmental. We only do the 8E, TSCA 8E, where like if there is any concern about potential health effects that are not declared in the SDSs, IH got involved from the exposure perspective, and that's all of our extent. And that has changed really since 2016. This slide is a little bit old because they've TASCA is evolving as we speak, and we'll talk a little bit about that. But I just wanted to put it into perspective for you. This is what we were looking at a few years ago when TASCA was updated. So 1976, many of you were not even practicing at the time. We had the Toxic Substances Control Act, and it became a law. And it was a great idea because it's more for chemical management, right? So you had to register all of your chemicals and all of the controlled measures that there are. So there, since then, we've had an inventory of chemicals that are already in the market and they're already registered. And there is a process for new chemistries. If anybody wants to import or manufacture new chemistries that are not in requirements right now, they have to go to EPA and submit toxicological evidence, ecotoxicological measurements, and a prediction of the potential exposures you would have in the workplace and in the communities, and so that EPA will allow the use of that given certain controls, either emission controls, PPE, engineering controls, etc. Right. So in 2016, there was a recognition that really the process wasn't modernized anymore, and we needed to update it. And it was passed with broad bipartisan support in Congress by industry. NGOs supported it because we really recognized that the risk evaluations had to be updated and the risk management has to be updated, particularly, especially for some of us who are already in the participating in chemical management in Europe and in Asia, where they are going in much more advanced in the risk evaluations, right? So what does that mean? So there was kind of this inventory reset where EPA said, like, we need to see what's in the market, right? Make sure that whatever is being manufactured, we know. Whatever stopped being manufactured, we know. And we have a better understanding of what's being used nowadays. One of the challenges is that EPA has this inventory. It's called the CDR, the Chemical Data Reporting. And again, unless you meet a certain threshold, you don't report it, right? So that's why it's really important to have a broader understanding of what's being used. The other part, and we'll talk a little bit more in the prioritization, it's not clear really still now. It's not clear what are the criteria that EPA is using to prioritize the chemicals that they're going to do risk evaluations on first, right? I don't want to be an employee of EPA because they have a very tight regulatory requirement on timing to carry out the risk evaluations, and they were not given enough time to develop the methodology for that, right? So part of my job nowadays is exactly that, is really advocate for clear and transparent and standardized science-based criteria so that we can have a systematic and predictable evaluation so we all know what we should be doing. Of course, there are fees associated with it, and manufacturers or importers are responsible for that. And so, of course, like industry wants the fees to be reasonable, and that the timing is good enough so that it doesn't impact speed to market, and that's another one. And the last one I'm not going to talk very much about is confidential business information, of course, trade secret protections and things like that. When you're doing risk evaluations, you have to understand what are all of the uses, what are all of the applications, and so it kind of bumps against trade secrets, right? So, but we won't talk much about that. So this is the whole gamut of the Frank Lautenberg Chemical Safety for the 21st Century Act, right? So I mentioned before, the first part is from left to right. So there's the inventory reset, again, understanding what are we still manufacturing, what are we still importing, what did we stop manufacturing and importing. Then comes the prioritization based on risk, right? And so depending on what EPA considers high risk or low risk, they were put in a low priority or a high priority. In 2016, there's a list of about 70 chemistries that are identified as high priority. And EPA is required to pick 20 of them and do, initially was 20 every 3 years. Now they're changing a little bit, and we'll talk about the progression of TSCA as we're going. Okay, and so those are going through risk evaluation, and the outcome of the risk evaluation is, does it present it doesn't present unreasonable risk, and therefore there is no additional actions, there is no further actions, or presents unreasonable risk, which then means that EPA has the mandate to implement additional regulations to minimize that unreasonable risk. As I mentioned, and we're not going to cover that, but it's also important, I think, industrial hygienists have not been, or at least my experience, very few hygienists have been involved in the new chemicals and new uses. I think now with the modernization of this law, this is a great opportunity for us to get engaged. And I will talk a little bit also in the effort that we're doing in AHA on this one as well, because this is a really key aspect of our profession, right? So it's rather new our profession and really stepping into an area where we should have been engaged all along, but it has been kind of like left to the product stewardship folks. So today I'm going to concentrate more in really the high priorities chemistries and the risk evaluations, and we'll talk, now that we have some information, we'll talk a little bit on the regulations and what is EPA doing about this. For those of you who know or don't know, I just wanted to put this out there. We have, EPA had the first 10 chemicals. It was kind of like a test case. EPA thought these are very data-rich chemistries. They thought it was going to be relatively easy. They are used in industry and some of them in consumer products. So they had the whole gamut. And they were supposed to be done by 2019. We'll talk a little bit of the evaluation of that. So all of the risk evaluations for the first 10 chemicals are either done or in the process of being finalized and providing comments to EPA. One thing that I forgot to mention, and I apologize, I'm going to go back. One of the things that we have is that EPA has comment periods in each one of the steps. So when they do a risk evaluation, there is a scoping document and a risk evaluation document that EPA puts out, and we have comment periods for each one of them. And the same thing when there's unreasonable risk, you have comment periods, and when it's the regulation proposed, we have comment periods. So I hope that by the end of this presentation, you are fired up and willing to provide comments to EPA in each one of these spaces when the opportunity arises. Okay, so with that, we are in the, as I mentioned, the risk evaluation is done for the first 10 chemicals, and EPA is in the process of deriving risk management measures for all of them. Most of you might be aware that for asbestos, the risk management rule has been promulgated and the comment period actually ended. As you know, for chrysotile asbestos, EPA is proposing to eliminate all of the use within 2 years. That's the proposal. We have methylene chloride, and I have a slide on methylene chloride and perchloroethylene. Both of them are proposed rules, and we are in the comment period for those proposed rules. So with that, I'll invite you to provide comments if you think this is something that would be opportune for you to provide comments on. So the next 20 high priority chemicals as listed here. And you can see again, there is a wide variety of them. We have a lot of the phthalates in there. still chlorinated solvents, and now we have formaldehyde and butadiene that are slightly different because they are more in the gaseous solutions, gaseous phase than in the liquid phase. So applications in the consumer products is slightly different. So we'll see how that works out. So one of the mandates that EPA has, and you're like, what are we doing here? So the issue is that the mandate for EPA is that they have to protect the health of all of individuals, including susceptible individuals and sensitive individuals. So worker population is considered a susceptible individual because they are expected to be exposed at a greater proportion than the general population. And that's why EPA has taken on the role of also doing the risk evaluations within the workplace. So here is kind of like the way EPA thinks of the life cycle of a substance in commerce, right? The one that we have here is for perchloroethylene, but again, they're very similar everywhere. And you can see here that it's slightly different than the majority of us think of it, right? So EPA thinks of manufacturing, processing, industrial, commercial, and consumer uses, and then of course releases and disposal in the environment. And so for many of you, like manufacture is not one plant, but multiple plants, and even going even further than that, like to me, manufacturing means a bunch of different units with different similar exposure groups. So you can see when EPA is looking at this in a more holistic way, it's really grouping a lot of different processes probably all together, right? Then we have, of course, processing, and sometimes in the manufacturer we'll also have processing, right? Many times manufacturers of the pure chemistry will also use it as an intermediate, as a feedstock for something else, or use it as a reactant or as a catalyst, right? So we'll have all of those. Of course, you have incorporation into mixtures or just like repackaging to be sold somewhere else. And of course, there's the recycling side. And of course, all of the uses. And you can see how you can imagine, and we can discuss that later on if you want, how the industrial, commercial, and consumer uses might differ in the types of applications and in even the concentrations of some of these chemistries. But this is how EPA is looking at them. And of course, last but not least, the disposal rights. So there is workers that are working in the disposal and recycling of these products. And so EPA looks at that as well. The other key element here is that this life cycle is not only to see the exposure of the individuals, but also you can see releases to the environment in all of these steps. That's why EPA also looks at what's happening to air, water, and soil. Once we've identified all of the potential uses, EPA develops this conceptual exposure model where each one of these uses will have releases to the environment, either like directly, where you can have contact with, in this case, because it's perchloroethylene, right, liquid contact, then you can have thermal exposure, potentially just to workers, but and we'll talk about the occupational non-user, who that is, right? You could also have, for perchloroethylene, it could be evaporated as well. So you can have inhalation or even thermal absorption of the vapors. And again, you could have workers and occupational non-users. And of course, you'll have from the manufacturing or producing facilities, you could have fugitive emissions that will lead again to inhalation. And so many of you at this point in time might be wondering, what is an occupational non-user? And the initial discussions EPA had and initial comments that they had were like, well, how about the child of the owner of the dry cleaner who comes after school and stays in the dry cleaning store with their parents, right? So that is clearly somebody who is not intended to be there and is exposed to occupational level exposures, right? And many of the manufacturers said that doesn't exist. We don't have that in our workplace. All they said, well, how about the accountant or the HR manager who walks around the plant? And for many of us, I can tell you, in a large manufacturing operation, that doesn't happen either. But we do have occupational non-users. How about your scaffold builders? How about your electricians that are coming, or like those who are maintaining their remote sensing operations, right? Or some of the supervisors that are just coming around, they are considered occupational non-users. And one of the things that we've mentioned to EPA is the fact that because of OSHA, we do have temporary restricted areas where people would not be in the space where you're having releases to the environment. And the challenge that we have, and we'll talk a little bit about it further on in the presentation, is that what EPA is considering a safe level is not necessarily what OSHA has been considering an action level. So we're having some of that duality here, and we'll elaborate a little bit more on this. But this is in general what EPA is looking at, and they are asking for information in all of these stages. And if you have any data and any of these stages, they are really hungry for information. One of the challenges that they've had, like many of us, they've had a massive loss of intellect. They are dealing with new hires who have to ramp up really quickly, and because they are environmental protection agency, right? They have not been necessarily in the industrial setting or in the workplace setting to in general. So it behooves us to really explain it to them and present it to them and show the practices that we have. Their objective is to protect our workers, and that's exactly our same objective, right? So I'm certain we are not perfect in our workplaces, and so it is a good time, and it's a good opportunity to evaluate how can we do better and protect our workers. Okay. One of the challenges that we have with EPA is that their initial risk evaluation was done considering the use of PPE and or considering engineering controls that we had in place. And they were supposed to do the risk evaluation for each one of the conditions of use independently. As you can imagine, that proved to be a massive challenge because there are hundreds of conditions of use just the way EPA looks at them, let alone like when we think of similar exposure groups, right? And unfortunately, when they did the first few risk evaluations, EPA was sued because they were considering PPE, and many of the NGOs said, you cannot rely on PPE. You don't know that people are being protected consistently. And that is probably more true in the smaller industries, is more true in those establishments that are not necessarily ruled by OSHA, right? And so EPA went back and revisited the first 10 risk evaluations and did two different things. They did not consider PPE, and they are now doing what they call a whole substance approach. So they might still be considering, and there might still be looking at doing the risk evaluations at each one of the conditions of use, as they call them, but they are ruling for the whole chemistry and not for each one of the conditions of use. Okay, so and I think I've been alluding to that through this whole presentation. One of the challenges that we have EPA wants data, and they really want to do a good job at doing the risk evaluation in a very consistent manner and trying to be realistic. And when we've submitted data, we've noticed that we have a massive challenge. The objectives of which the risk evaluations is different, right? We are trying to think of similar exposure groups, and my similar exposure groups might be similar or not to yours in your plant. We might have the same process or very similar. We might have the same names, but like the frequency at which we do things, the types of controls, and the administrative controls that we might have might differ slightly. But we do our risk evaluations and we implement our controls really specific to this particular SEG or this particular task. So now EPA is trying to bring it all in, aggregate it all together, and make decisions at the national level. And so, and of course, they are using data for the past 10, 20 years, which might or might not be relevant for the reality that we have now. It was developed for to comply with the PELs, the OSHA PELs, or the ACGIH TLVs, right? And not necessarily to what EPA is expecting we should be controlling the chemistries to. So really, the objectives are differing, and that doesn't mean that we cannot use this data. What it means is that we need to really engage in conversation and help them understand how to better leverage this data, to use this to inform their risk evaluations. So I'll briefly put here some of the contrasts that we have in each one of these frameworks that we have, right? So for us, like the first question is like, what is the question that you're trying to answer? What are you doing these assessments for, right? So for us in industrial hygiene, typically, and this is in generic, right? So many of you can tell me, it's like, well, for research, we do it differently and things like that. But in general, and the occupational health level, right, we are doing the exposure assessment to first assess if we're compliant, or to determine if we need any additional risk management, or to validate our risk management measures already. Versus EPA's question is, what is the health risk, right? In terms of data collection and analysis, as I was mentioning, we typically follow the AIHA strategy that is being used by the occupational health professionals for decades, right? And it's a tiered assessment when you have qualitative assessment first to inform what are you doing your targeted sampling, right? And we rely on the similar exposure groups for the most part, right? And as I just mentioned to you, EPA is more concerned about the conditions of use. They realize that maybe manufacturing is just too broad of a term, or processing is too broad of a term. So now they are developing what they call occupational exposure scenarios, or OESs, right? And they want to aggregate data at the higher level, right? But one of the challenges is that they're also considering these occupational non-users. And so many of us might have done some assessment in an occupational non-user, probably when you're doing a turnaround, right? You had scaffold builders when you're venting equipment and you monitored the area with the scaffold builders, right? And in some cases, we might have some of those, but it's not a consistent approach just because we are following our tiered assessment, right? So that's some challenges that we have, and we'll talk a little bit more about that in a few slides. Of course, the analytical tools that we have are different, and the metrics that we use are different, right? The metrics that we use really depend, again, on the question and on the data that you're collecting, right? The type of hazard that you're controlling and what are you looking to control, right? The types of decisions that you're making. EPA, again, more used to what they do for risk assessment in the population. They look at the average and the high-end percentile of the distribution, And you can imagine then that when you are aggregating so many different worker groups all together, your high-end distribution might be penalizing some of your other groups, right? And the methodology on the risk assessment really depends on the health outcome. And I'll present you with I'll explain that in a little bit, right? And of course, the alternatives to quantitative assessments, we do follow a tiered approach, right? Because we cannot measure everybody all the time. And EPA is looking at more like focusing on the condition of use and the occupational exposure scenario. So we still have a little bit of attention there in how to better use our data. Okay. So just to bring it back to numbers, just because I like them. So oh, that's the other thing, right? EPA is more used to not necessarily a very long normal distribution like we are, right? And so for IH, we typically use it for our long-term averages, for our full shifts, right? We tend to use the upper confidence of the mean, right? And compare it to the OEL versus EPA in the health risk assessment, they use either the arithmetic mean or the 95th percentile of the distribution to determine what is the average concentration or the daily concentration or the lifetime average daily concentration, right? And they use that to compare to calculate what we call a margin of exposure for the non-cancer hazards, right? Or the risk, where they're using the unit risk factors. So it's more based on the potential risk of excess cancers when you are talking about cancer, right? So of course, the exposure metrics are different because their objectives are different. So how do we help them use our data for an objective that is completely different for which we collected our original data? One of the biggest challenges that we have is that EPA is making decisions on the unreasonable risk only on the high end, right? So you can see here, this is just for manufacturing, and if I'm not mistaken, this is still for perchloroethylene. So they had some data for inhalation and some modeling. And for acute non-cancer, notice that for the central tendency, they did not find a reasonable risk, but for the 95th percentile of the distribution, they did find unreasonable risk. That's for non-cancer, for chronic non-cancer, and also for cancer. For dermal, of course, many of you know that we don't have quantitative means to systematically measure dermal exposure in our workers. So they used fairly conservative models with very conservative parameters to estimate exposure. And of course, when you are not considering PPE and substances that are already classified as carcinogens or acute irritants, you're going to have risk. So not surprisingly, they found risk for the central tendency and the high end. One of the challenges that we have is by not having a lot of information and by not considering PPE, the models are assuming that an individual is exposed to the chemistry by immersing both hands for 8 hours into the chemical, which of course is very conservative. It's very unlikely that we have workers doing that, at least in the industrial setting, right? So, but again, this is only for EPA to determine there is some reasonable risk. We need to implement controls, right? So, and that will come in the risk management phase this time, which it's like it's separated one from the other, and that's what makes it really hard. Okay, so one of the things that we've noticed, unfortunately, is again because EPA didn't have enough time to develop a consistent approach and develop all of the methodology before stepping in to doing the risk evaluations, we see that things are changing as we move, right? So Initially, there was a scoping document to define what conditions of use were available or not. And now we find that EPA is changing and adding or removing conditions of use depending on requests of people. Actually, I have not seen one condition of use being removed. It's just we keep adding conditions of use or populations that can be of concern. We had the risk determination by conditions of use, and now they're doing the whole chemical determination, which we still don't understand exactly what that means. Initially, there was no evaluation of emissions to air, water, or soil because we already have the Cleaner Act, the Clean Water Act, and all of the disposal controls, right, or regulations. And now EPA has developed this fence line screening and looking at what we call fence line communities, right? And want to look also into aggregate exposures and kind of like go into the environmental justice aspect of the risk evaluation. Before, as I mentioned, we had PPE considered. Now we cannot consider PPE. They had an occupational non-user, and they were trying to look at that as well. And now, like, they developed this existing chemical exposure limit, and we'll talk a little bit about that. And so we still don't know how does it apply. They were trying to do base available science and like updated information, and now they are like, because of the lack of time, they have to use default assumptions, and they are defaulting to IRIS, even though IRIS in many cases might have been done 10, 20 years ago. There might be some new data available, right? So we have some challenges, and we're still working with EPA around this, and that's one invitation for you to get engaged. I'm going to speak very briefly on fence line screening. This is a proposal. It hasn't been used yet in the risk management set of this, but basically, as I mentioned, they are looking at communities within 6-mile radius of your facility that could be impacted by emissions to air, emissions to water, emissions to soil. And what they're saying is, well, if we don't see any unreasonable risk, then no restrictions, we're good. If we see unreasonable risk in the workplace and unreasonable risk in the fence line communities, then we are suggesting to ban the chemistry. If we see unreasonable risk in the occupational environment and only unreasonable risk due to fugitive emissions, then they proposed additional controls for fugitive emissions through local controls in your plant. If they see that the impact is due to area sources, then they want to leverage the Cleaner Act, which means basically implement additional emission controls in our sources, right? So again, this is just a proposal. We don't know exactly how is EPA intending to do that. They set this proposal out. If you want, I'm happy to send you I mean, it's publicly available, the proposal, and then the Science Advisory Committee on Chemicals provided feedback, and they are going back to the drawing board and implementing the changes that the Science Advisory Board recommended. So we don't know exactly how are they going to be tweaking this yet. The other part, again, this is what happened with 7 of the first 10 chemistries, and they haven't done it after that. But one of the challenges is that if EPA considers that there's no occupational exposure data available, or if it's not enough, because you need to characterize any specific scenarios, or again, thermal exposures, or you don't have enough information about the occupational non-users, EPA can ask, and they have the regulatory jurisdiction for doing that, to request test orders. And this is a mandate. You have to comply with it, right? One of the challenges that we have is that they have to follow EPA guidance and not OSHA or NIOSH strategies. So some of our colleagues have dealt with that and tried to negotiate with EPA and trying to understand. For example, one of the challenges that we have is that they do not accept AIHA certified labs. They want GLP labs, right? So we work really hard in explain to them what is the difference between the AHA certified lab versus a GLP lab, why one applies and the other. And they have a lot of concerns in like sampling strategies and sampling methodologies and things like that. So there has been a lot of back and forth with the organization. I don't want you to look or read any of what's in here. I just wanted to showcase the level of information that EPA is asking in this test orders. And actually, if you're submitting data, they want to see all of this information. Anything that is in green, right, is what is typically available in your reports, right? Like purpose of the sampling, sample type, duration, the concentrations, when did you sample it, the method that you use, the job titles, et cetera, et cetera. That's about 25% of the data that they're asking for. Anything that is in blue is things that are available, but you don't typically have it. Again, because you are working with your particular unit with that similar exposure group that you know very well, and you don't need to extrapolate everywhere else, right? So your shift duration, location of your sample, the data acceptance criteria, all of your pump calibrations, your change of custodies, all of your notes and things like that, they are available, but you don't have it readily available in a report, typically, right? So that's about 10% of the data. What is in brown are things that are unique to the unit. Again, you can retrieve it, but it's not only just IH. You have to engage other people, right? So like the engineering controls that you have in place, the administrative controls, the room volume, the ventilation rates, and things like that. And that's about 40% of the data that they are asking. And last but not least, some things that are unique to the site and could be construed as confidential business information, right? Like the PNIDs, the layout of the plant, the diagram, the frequency of the operation, and our information about the individual age, work history, and things like that. So it's just a challenge to have all of that. You might be aware that AHA and NIOSH are working in a rationalization of data and trying to harmonize data requirements. Hopefully that will help all of us out in trying to better characterize our samples and maybe help for data aggregation in the future, but that's not what we have right now. And this is again, so far, test orders have been issued for 7 chemistries. That has proven to be, of course, the other thing is that if you have 7 plants that are manufacturing this product or using this product, you have to do representative sampling in all of them for all of the job groups, right? So you can imagine how much work this is. So again, there's been a lot of back and forth with EPA trying to rationalize this and how can we get representative information without having to collect samples for decades, right? And so EPA has realized that maybe that is not the best way. So for now, we're not expecting any test orders, but they are not off the table. And for the future risk evaluations, you might get the test orders before we start the risk evaluation. So, and that is part of what EPA is calling the tiered data reporting rule that is coming out for proposal, I think, next month. So stay tuned. One more thing that I wanted to share with you, I know I have like a few minutes left. I wanted to share what EPA is calling the existing chemical exposure limit. So they say consistently that OSHA PELs are out of date, and they might not be representative, or they are might not be protective enough. And so they have developed ECHLs for the first 7 chemistries that they have developed, and their approach is slightly different. And so here is a comparison of the yellow bars are how conservative is the ECHL relative to the PEL. Please notice that the scale to the left is in negative and is in logarithmic scale. And the blue bars are relative to the TLV. So you can see that for asbestos, the proposed ECHO is about 20 times lower, whereas for trichloroethylene, which hasn't been promulgated yet, it could be anywhere between 2,500 to almost 10,000 times lower. And you can imagine that, of course, we have, like, at this point in time, there's no way we can prove that our workers are not exposed to those levels. One of the challenges that we have is the analytical capabilities of our labs and our methodologies to be able to reach these levels. So these are some of the challenges that we are having, right? So kind of to give you an explanation of why this is happening, it's just that, again, this is EPA is using cancer risk and using what they call the unit risk factors to calculate what is the acceptable level. And of course, when the unit risk factor is for a lifetime, so they do average out the lifetime versus the working lifetime, right? And that's why, and again, depending on how they derive this, basically the slope in the dose response curve, that's why we have very conservative values. Not only that, but they're doing the calculations for both cancer and non-cancer endpoints, and they're using very susceptible endpoints like for perchloroethylene. I think one is that, oh, okay, that's my timer. I have 10 more minutes for you, so I can have enough time for questions. So for the non-cancer, they're looking at any health outcome, and that could be anything from losing visual acuity, even if at transient endpoints, they're also using that. So you can see how conservative some of these values are, okay? So we're gonna talk really briefly about risk management measures. And now we know some of the risk management measures that EPA is proposing. So EPA has a whole menu of risk management measures they can use, right? They can prohibit or restrict or limit each one of the conditions of use, or they can prohibit or regulate each one of them, or they can just ban it straight out, right? They can require additional monitoring or additional record keeping. They can require additional warnings or instruction through your SDS and through your value chain. They can require additional PPE. If you have been involved in the new chemistries, in the PMNs, you can see that EPA mandates specific PPE that is not necessarily in line with what we're used with OSHA. Even the terminology is slightly different, so it creates some confusion sometimes. They can, again, require biomonitoring and additional record keeping for the workers, for ONUs, and even for the communities. Additional training or registration. We don't really know what else. Now, with that, we know that we've seen two risk management measures or rules that have been proposed. I didn't put asbestos here because it's just banned, so we're not going to go through that, right? But you can see here how the values, the ECHOs, are fairly low compared to what we are used to. They are banning all of the consumer uses for methylene chloride or perchloroethylene. So if there will, for methylene chloride, by next year, if the rule is passed as is, there will be no more paint strippers or anything like that allowed for professional or consumer uses. About 25% of the industrial uses and commercial uses have been banned. For perchloroethylene, it's about half. And so they are also considering some restrictions for banning for example, commercial furniture refinishing. That is going to be banned, but that's straight out banning versus, for example, for perchloroethylene, it's a phase out, and they're giving it 10 years to do that. They're also, for now, considering exemptions. So you can, if for example, for methylene chloride, there are some critical uses that NASA and Department of Defense have identified for aircraft. And so they are allowing a 10-year phase out, but in that 10 years, they have to implement what is called a workplace chemical protection plan. And if you go into that, it somewhat mirrors the OSHA standard without the biological monitoring, and the controls are a little bit more stringent, and reporting out requirements are more stringent. And they're allowing some alternatives for 7 additional uses. So you can see that for perchloroethylene, they've gone with, again, very strict controls in the workplace and very prescriptive controls for particular conditions of use, right? So again, for different applications, they're banning it or they're allowing it. So it's very difficult so far. We don't know exactly. Again, this is kind of the first 2. We're working through the kinks. Industry and hopefully AIHA is also engaged. We're trying to get to something that is more consistent across, so it's more predictable, the types of controls that we have to put in place. But for now, it's still in the works, right? So with this, I wanted to kind of like show the potential impacts that you have for these risk management rules, right? You can see like how you're going to have increased reporting, increased engineering controls. You might have additional, so for now, we don't have additional emission controls, but they might come to that. We don't know yet. We already see the thinking of asking for fence line monitoring requirements, right? For us, for occupational health, you can see how you will see if you delve into the workplace chemical protection plan, you'll see that there's additional training and record keeping, additional monitoring, change in the monitoring strategy, and additional PPE if your condition of use is allowed. But then we can go to the users, right? You can see that one of the challenges that we're going to have is the substitution in process formulation. So if you are one of the users, you're not a manufacturer, but now you are in the receiving end of this, you might be facing with additional controls that you have to put in place, or straight out banning of your product. So you're going to have to recertify some of your additional, your uses, right? Or your chemistries that you're using. And you have to also do additional controls. One of the things the rule has always said is this is on the shoulders of the manufacturers or importers, but the risk management measures are really impacting the whole value chain. And that's why this is a lesson learned from the first term chemistries, where they were only focused on the manufacturers and maybe just the first processing industries. But now we're realizing that with the risk management rules, it is very important for the whole value chain to be engaged and provide information to EPA so that they have an idea of the magnitude of the impact that they're putting into commerce, okay? So I do have just a few more minutes. So if you bear with me, I was gonna show a case study with something that we have done in the Butadiene Consortium, which I think was very, it was very useful. We don't know. We are going through the process right now. But I'm going to close out with the impacts in the community, in the IH community, and a call out for you. So one of the things that is very critical really is, again, showcase what is the process in commerce and the uses that you have. You might not be a manufacturer, but if you're a user of that, it's really critical. You might say, well, I'm a user, I don't have hazard characterization, but you might have epi data, for example. You might not do tox studies on that, but you might have epi data that could be of use. For sure no, but some of us have occupational exposure information, and it's teaming up with your environmental counterparts to also showcase the environmental release information. I'm gonna toggle through real quick. I think we've already covered all of this. But one of the challenges that we have, of course, right, is that it is very likely that we have more data at the manufacturing and the processing stages and a lot less data in the consumer stages. But again, so helping EPA understand this and helping understand how they can evaluate the risk of this without necessarily having all of the occupational data, but other surrogates or ideas would be very helpful for them. This is what we did. We shared also the controls that we have in place. Of course, we have the luxury that butadiene is a carcinogen. It is well known. We have an OSHA standard, right? So there is a lot of things already in place for that, but that might not be the case for some of the other chemistries that are under risk evaluation right now. Okay, so with that, I wanted to close with this is not an environmental thing anymore. This is not IH only anymore. This we need to engage with EPA in a really interdisciplinary fashion. We need to have our process engineers or our research folks interacting with them. Of course, IH, I put safety in there because for many of us, all of our IH controls are under the safety standards or the site safety standards, and some people call it differently, but in general, they are like hand in hand. Of course, we have to have our environmental folks and our environmental engineers, law, because you might, through your mind, I'm sure some of you have already thought of like, what is the intersection of EPA and OSHA and some other laws that are already in play? How do we do that? And of course, senior management has to be engaged so they can support all of this, because you can see how there will be a cascade of effects that we're not seeing, right? Like, well, hazard communication, how do you do that? How do you qualify your products? What are the quality assurance of this? I mean, again, processes, process changes, metallurgy, and all of that we can spend another 45 minutes on this, right? Again, the impact might not only be for us, the manufacturers and the direct users, but also indirect users. What if your product is changing, right? We're going to have to reformulate our products. Are you going to have the same effectiveness of your products? Are you going to have to change your processes? Do you have to substitute your materials or your derivatives? So you can see how we have to get everybody engaged in this early on, because many of these processes might take a long time, right? Of course, I mean, if we are not able to use our strategy, what is it that we're going to be doing, right? So do we characterize our occupational non-users? What are the criteria do we have? Can we apply a tiered approach with that, right? How do we contextualize our data? How much of our data do we need, right? What is the criteria? If we cannot use a similar exposure group, and we have to have random sampling, true random sampling, how do we do this? How much time do we have in this, right? How will the data be reported? And how many times do we have to report it? Is it one time for the risk evaluation, or do we have it continuous? Apparently, in the first two rules, there's no room for us to report it or store it, like for OSHA. So we don't know exactly what that means, right? And what is the minimum set of information that we have to have, and for what objective, right? So these are a lot of questions that we will be grappling with in the next few years, really. And that's why I'm calling you to engage through your professional associations, through your trade associations. And if your chemistry is involved, I encourage you to get engaged in these discussions. Of course, what are the impacts to our occupational health programs, as I was mentioning? Are we going to have dual regulations like we have in Europe? How do we communicate the risk to workers that, like, we've been telling them they're safe with the PLs or the TLPs that we have now? How do we communicate now that suddenly we have to control to something that is 10,000 times lower? Like, how do we communicate that, right? We're going to have to develop new sampling methods, right? Because we're not going to be able to measure to the equals with the current standards that we have, right? What are the programs? What are the impacts to our programs that we have, right? So you can see how we have the work cut out for us. I'm excited about this. One of the things that I wanted to mention as well is that at AIHA, we're trying to stand up a task force to provide education and engagement with EPA, again, to showcase our profession, to educate them on what we have, what we've been doing for the last 5 decades, right? And what can we bring to the table to help protect the workers. So with that, I thank you for your time, and I am open for questions if you have any.
Thank you, Dr. Maberti. If anyone has a question, please type it in the chat and we will read it out. Eric Kitten said that it was very, very informational and he thanks you.
So I know this is a lot, and for many of you might be very new. And Dr. Whitehead and some of you have my contact information. Please feel free to reach out to me. Also, AHA, Larry Sloan, and Mark Ames are engaged in this. So we're happy to talk to you about it offline if you want.
Jacob Domini and David Spalding also say thank you. So it looks like we do have a question from Alex. He's actually our next speaker. He said, has the EPA finalized their proposal for the reduction for MECI? I thought it was still in a final draft phase.
So no, there is the proposed is called proposed risk management rule is out for comments. It hasn't been finalized. I think the comments are due July 10th, if I'm not mistaken. So there's that proposed rule, and there is the perchloroethylene proposed rule. Both of them are out for comments. So please take some time to read them and provide comments if you see something relevant. If you don't want to provide comments directly, AHA is compiling comments as well. So I think the deadline is July. I think it's next week, the deadline for methylene chloride, and the 14th for perchloroethylene. So please reach out.
Okay, we have a question from Bill Young. Has this been implemented since 2016? Can I find info on EPA risk management's webpage?
For sure. You go to EPA, just Google EPA TSCA, and it'll take you straight to the TSCA website. It'll show you the whole process from prioritization to risk evaluation and risk management. You have links to each one of the documents, scoping documents, risk evaluations, finalized risk evaluations, and the proposed rules. All of it is in there. Actually, let me see if I can reach it out real quick. And I can put it in there. It's a lot. Each one of the risk evaluation documents is about 700 pages plus attachments. So, but hopefully you got.
Yes. So Dr. Brady did send a link to the chat.
Yep.
To the EPA website.
So you have the whole process, and you will have links to the documents for the 30 chemicals that are under risk evaluation.
Okay, if there are no more questions, we will take a 10-minute break. Be back by 9:50 for our next presenter, Alex Cardone, and he will be talking about the characterization of autotoxins within the Air Force and Eiler.
Thank you all.
Thank you, Silvia. You're the best.
Okay, welcome back, everyone, from your break. We will get started on our second presenter. Alex Cardone is a supervisory industrial hygienist for the Department of Defense and a recognized subject matter expert in noise and air sampling for a variety of industry settings. Alongside supervising a team of industrial hygienists, Alex is also an adjunct instructor at a local university. He has a passion for helping others understand the importance of workplace safety and has dedicated his career to promoting safe and healthy working environments. Alex is a highly respected professional in his field and is committed to providing innovative solutions to challenging industrial hygiene problems. He is an active member of several professional organizations and frequently gives presentations at local and national levels on the latest developments within the environmental, safety, and health field. So please, everyone, welcome Alex Cardone to talk about characterization of autotoxins within the Air Force in Eiler.
Thank you so much for that introduction, Serena. I hope everyone can hear me. I am very excited to be able to address and talk with y'all today. I'm right now just bringing up the PowerPoint. So hopefully you don't have to just look at my black screen. So I'm sure that would be appreciated. All right, that works. Thank you so much. I appreciate your assistance in that. Again, my name is Alex Cardone. I am a supervisory industrial hygienist for the Department of Defense, currently stationed here at Hill Air Force Base over in Utah. If you're not very familiar with Hill Air Force Base, it is one of 3 of the depot maintenance level bases for the Air Force, as well as if you're not very familiar with really how the military structures and as well as governs and kind of divides up its workload. Every single base has a very specific mission that it seeks to be able to carry out and be able to perform. Hill Air Force Base is one of the very unique ones. It is one of 3 that seeks to be able to provide maintenance for several different airframes or aircraft, including the F-16, A-10, and C-130. And this includes, as far as performing maintenance, resulting in the complete strip down of the aircraft to nuts and bolts, and also just the regular maintenance, the equivalent to an oil change that comes in. There's a variety of different hazards, and it's actually the top base for the characterization of hazards. We have roughly about over 8,000 identified occupational hazards present within our base, but I guarantee there's a lot more, as we're currently working with about a 30-man team, split up into different groups with different focuses. However, it helps to be able to understand that framework on kind of how the government approaches the characterization of not only hazards, but ototoxins. If you could be able to go to the next slide. So just a little brief outline. There are 2 big topics that I'm wanting to be able to cover during this section here. That is to be able to go over autotoxicants in general, mostly their impact on hearing loss, that as we currently understand, and as well as how the government, at least the DoD side of the government, emphasizes and addresses that impact, as well as a little bit of a brief backstory about inner ear anatomy, just to better understand what the overall impact on ears and hearing loss is according to recent data that we have available. And also industry chemical examples, just so that you can better relate to possibly organizations, industries that you may be a part of, so that you can kind of have a more targeted approach if you're reflecting upon your own organizations, as well as a focused approach and impact that the government, specifically the DoD, is taking to be able to address, control, and characterize ototoxins. At the very end, going to be going over a system and it's a way of thinking known as EILER, otherwise standing for Individual Longitudinal Exposure Record. Say that 5 times fast. But ultimately, this is a method we'll go into a little bit more, talking about some of the shortfalls and demands that EILER has and the overall benefit to having an EILER mindset, regardless of what industry you're in, just as environmental, health, and safety professionals, on how it can be able to help us. If you could go to the next slide. So an emphasis on ototoxins. So I guarantee this is probably not the first time that you've heard of ototoxins. If so, you're in for a treat and you're in for a wild ride. I know whenever I first really heard about and started looking into ototoxins, the biggest thing that I realized was, again, how the interaction between chemicals, both chemical and physical hazards, can be able to truly impact as far as our worker health and well-being. Ototoxic chemicals, they're not new, but with them not being new, although we've known about them since about the 1970s, even some earlier reports suggesting their impact on worker health, research has still been fairly sporadic. It hasn't been until recently, the past about 15, 20 years, that there's been a lot more developing research that has been able to go over what these ototoxic effects are and also ways to potentially help mitigate it, as this is a very difficult issue on being able to identify, control, and develop a causation strategy so that we can better tackle these issues. Some other interesting notes are just some of the other approaches that neighboring countries and around the world are taking. In fact, Australia and Brazil, one thing that I had learned was actually that workers' compensation claims for ototoxicants has been included. That is actually a legal workers' compensation claim route that can be taken as far as that, again, that connection between ototoxicants and hearing loss. These countries are already taking those steps towards making that connection and helping ensure that employers are being held responsible for these worker health situations. Similarly, ACGIH, they've adopted back in 2019 their OTO notation within their TLV book, further thus identifying and helping assist professionals with identifying what exactly are ototoxins. And again, if you've spent even about 5 minutes of research, you will find out that there are hundreds, if not thousands of chemicals that may either have a confirmed or a suspected ototoxic effect with or without the presence of hazardous noise. We'll go into that a little bit more. But the United States Air Force, as I'm the most familiar with that, as far as their approach, really has put in a very large emphasis and a requirement from our career field to evaluate, characterize, and as well as control ototoxins within our specific bases. And coming from a base where we have already roughly about 8,000 different hazards characterized, this is a hefty feat. And it's something that has caused us to completely flip around and reevaluate how we approach evaluating toxins and evaluating hazards within the workplace. If you go to the next slide. Thank you. So the uncertain impact of ototoxins. One of the biggest questions whenever it comes to ototoxins is directly, how do they contribute to hearing loss? And that's one of the most difficult things to answer as well. We have a lot more studies that give hints and can be able to give a little bit of further direction. However, it's still the biggest question. If you're exposed to xylene within this amount, how much exactly is that going to contribute to your hearing loss? And that's a very difficult and that's a very hefty question to be able to throw around and to ask. But there's small steps slowly being taken to better understand that. Some of the difficulties whenever it comes to ototoxicants is that it's not just through an inhalation or it's not just through an absorption route. It's feasibly through all traditional routes of exposure, whether it be inhalation, absorption, or ingestion. Therefore, meaning it's a very multifaceted hazard that we're needing to evaluate and look at. Same thing. One of the biggest unknowns with ototoxins is the exact effect that it has within our health system. Specifically, that various different ototoxins have varying degrees of individual additive. I'm sorry if you could go back. Thank you. There's varying degrees of both individual additive or synergistic effects, whether combined with noise or not. A great identifier of this is that there was a DoD study back in 2017 that evaluated industrial shipyard personnel. That picture on the right, if you're not too familiar, just a basic industrial shipyard, a lot of maintenance goes on, therefore a lot of chemicals, a lot of interactions with heavy metals, and a lot of various different hazardous processes that occur at once, but in addition to a lot of noise. So, from this research study, they took nearly about 1,600 individuals, both within their current work, and they divided up into 4 different groups. Those who were exposed to ototoxins and hazardous noise, therefore above the 85 decibel range, so they were more following the ACGIH standard for their 8-hour TWA. So those exposed to ototoxins and hazardous noise, those exposed to ototoxins and not hazardous noise, those exposed to only hazardous noise, and those not exposed to either. And looking to be able to compare and contrast all of them to be able to see, to kind of glean a better understanding of what impact do ototoxins have. Their biggest cutoff point was they were looking at their focus group of ototoxin individuals exposed to ototoxins at the OSHA action level. So just as a recap, OSHA action level, I can be able to send that out. As far as I see Dr. Whitehead asked for a reference of the shipyard study, I can send that out in the chat during the questions portion. But the ototoxin, they analyzed that the group that experienced the most significant impact were the individuals that were exposed to ototoxins at the OSHA action level. So at the level where OSHA is now demanding that employers really start looking at, evaluating, and understanding how to control these chemical exposures, and were impacted by noise that was less than 85 dBA. They found that this group significantly had a 2.4 odds ratio of developing a permanent threshold shift compared to the reference group. And this is a very significant finding in being able to understand that even without the presence of hazardous noise, ototoxins can play a very large role whenever it comes to how to the overall hearing loss effect that our workers may have within any industry that we have if these ototoxins are present. If you could move on to the next slide, please. So this, I'm going to go over it really quickly. I believe that all of us should have a fundamental understanding, but I wanted to reemphasize that fundamental understanding of ear anatomy, just on a very general and micro scale. Inner ear is ultimately made up of 3 different parts: the outer ear, the middle ear, and the inner ear. It's important to understand this because each one has its own unique function and how it's typically damaged or malformed to impact hearing loss. If you could go to the next slide. Starting with the outer ear, anatomical parts include the pinna, or really just the outside, really the only visible part of the ear itself, and the ear canal. The main job of the outer ear is basically to act as like a satellite dish and focus in sound waves as they're coming towards an individual so that it can be transferred into the ear canal, and therefore those vibrations and those sound waves can be transferred to the middle and inner ear for interpretation. Damage could be caused whether birth malformations, physical trauma that can occur. Those things can be able to impact our overall ability to be able to hear and interpret noise. Could go to the next slide. Next, we go into the middle ear. So again, the sound waves, they've just made it through our ear canal and they reach the very first part of the middle ear, which is our eardrum, our tympanic membrane. It's in a giant sheet, almost kind of similar to a trampoline. It bounces. It turns these sound waves into vibrations that are able to travel through 3 very small bones: the malleus, the incus, and the stapes, otherwise known as ossicles. These 3 bones operate to be able to amplify those vibrations so that they can be interpreted better by the inner ear in a pathway that the inner ear can be able to better understand. And so another fun fact actually is about the ossicles themselves. One, there's the smallest bones inside of the human body, and there's a lot of skepticism that these bones actually originate within your jaw, and they actually migrate up into your inner ear. That's not really important. It was an interesting thing that I was researching and found out. I thought that was fascinating. The other interesting thing is actually, I believe it's reptiles and birds only have 1 ossicle bone instead of 3 small ones, and it actually stays connected within their jaw. And that actually is able to better help them in being able to detect whether movement or various different sounds whenever it comes to predators, as they typically are lower to the ground as far as on the reptile function. Either way, side note, I go on a lot of those. But the middle ear, damage could be caused by this physical trauma, such as puncturing that tympanic membrane most often. Physical noise, as far as if the sound waves are too intense, it could damage that that tympanic membrane, or potentially jostle those ossicles in a wrong way. But otherwise, another impactor that could be able to affect the functionality of these is ototoxins. A very good example of this is right here, the stapes. It has a muscle known as the stapedius muscle, very aptly named, The stapedius muscle helps to be able to operate MER, which is the middle ear reflex. If our brain is able to detect that there's a very loud sound wave or very powerful sound wave coming into our ear, the stapedius muscle can actually act to be able to help dislocate or gather distance from the stapes and the rest of the inner ear. This is able to help further allow us to dampen out some of that noise so that we're not getting the full impact of this intense sound wave that our brain is trying to interpret, and thus trying to limit that disease, or not disease, that impact and damage that could be done to the inner ear. The interesting thing about it, and it's a spoiler alert for a future slide, is that studies of benzene exposure have actually been shown to target that MER, specifically the neurons within that reflex of the stapedius muscle. Therefore, that muscle is not able to react the way that it can, and we're exposed to that full brunt force of that noise that it would have tried to protect us. But just as an interesting side note, we'll talk about that more in a little bit. If you could be able to go to the next slide. So, sound waves came in. Tympanic membrane turned them into vibrations. Ossicles amplified them. Now they've reached into the inner ear, specifically the stapedius connecting into the oval windows of the cochlea, that snail-like structure right there. The inner ear is made up of 3 different parts: the semicircular canals, which mostly deal with balance, but then as well the cochlea and the auditory nerve. So the primary function of the inner ear is to be able to take those intense vibrations that were just created by the tympanic membrane and to now send them throughout the cochlea to be received and have its inner hair cells react and create electrical impulses so that the auditory nerves can send those impulses to the brain and be interpreted as sound as we know it. So right now, you have various different hair cells within your cochlea that are reacting to my voice and telling you as far as how deep or how high my voice is, and better translating these vibrations and impulses into sound. And some of the biggest damage items that can be able to occur, or how the inner ear gets damaged, are due to physical noise or ototoxic effects that can be able to happen, as there's very, very intricate and very delicate systems and biomes that are occurring right here. Throughout this entire process, one of the common things that we see associated with hearing loss is presbycusis, just aging, and that's hearing loss due to aging. And what we commonly see is that within the cochlea itself, it's lined with 16,000 of these hair cells. As time goes on, these hair cells naturally deteriorate and naturally die, and it typically starts with the higher frequency receiving hair cells, and then it moves on forward. Just as a little bit of a background to better understand the cochlea itself. We're going to find and we're going to talk a little bit about a few different ototoxins which have an effect on those hair cells specifically, that can be able to better help us understand how ototoxins differ from physical noise and how physical noise impacts those hair cells. A really good example of that is, it's imagining you're walking through your yard whenever that you haven't mowed for a little while, so that the grass is standing up a little bit. If you step on that grass, it's going to bend, but with time, it's going to go back up and it's going to point up. It's going to be fine. That's very similar to our hair cells. As these electrical impulses are going through it and it's receiving it, it's like that grass is being tucked down. It's being activated. And as long as we're not activating it too much, those hair cells, they don't get damaged. That is their function. Same thing, as long as we're not activating it too hard, they're not going to get damaged too much. But the interaction of ototoxins could cause, or could affect, how that activation of those hair cells occur. We could go on into the next slide. All right, so real quickly, some industries that containing ototoxins. So these are just a very short list, but some of the ones that I feel help to very broad scope and illustrate a point. So various different levels of mining, various different levels of manufacturing, whether that be chemical, paper, machining, petroleum, various different utility utility industries, construction industry as a whole, agriculture, firefighting, pest control, printing, almost any industry that you can think of or that you may be associated with has a presence of ototoxins within it. And that's due to the very wide and spread out availability, or I guess abundance, almost ubiquitous nature that these chemicals are naturally found within as well. Another very interesting point is, if you're not very familiar with or have not worked with military bases in the past, is with the exception of about mining and agriculture, every single one of these industries is contained within every single military base in the world. At military bases, they're their own small community. They're a town, they're almost their own state. And they deal with almost every single one of these industries, sometimes on a very micro scale, sometimes on a macro scale. But it further drives that necessity on why this development and understanding of all hazards within the workplace is so critical. If you could move on to the next slide. So we talked about industries. Now let's talk about some of the specific chemical examples. And again, there are hundreds, if not thousands of them that are identified and regularly recognized or suspected ototoxins or chemicals with ototoxic effects. And I believe it's Canada recently came out with a they suggested that they had confirmed hundreds of ototoxins, but I'm not quite sure of how much the United States adequately directly influences confirmed ototoxins. But various different types of categories you could find ototoxins, you commonly find ototoxins, are various different types of solvents, whether that be xylene, toluene, methylene, methylethyl ketone, and benzene, asphyxiants such as carbon monoxide, various different heavy metals, cadmium or any sort of cadmium compounds, lead and inorganic lead. Same thing as mercury as well. Mercury is just a bad thing all around. We should just not play with it too much. Another very interesting understanding, and that y'all may be familiar with, maybe not, are pharmaceuticals. And regular pharmaceutical drugs, over the counter or prescription, also have been shown to have ototoxic effects, specifically impacting, again, the cochlea and the inner ear hair cells. Those things, some of the most common ones, include non-steroidal anti-inflammatory drugs, NSAIDs, and as well as acetaminophen. This is a very interesting factor to be able to consider, just if we have an individual that has a confirmed hearing loss case, but they're regularly taking acetaminophen or NSAIDs, which as an employer, we don't have a right to know that. That alone could be impacting and driving some of that hearing loss. So it's just another thing to be able to really keep aware of, and really as a training aspect whenever we're interacting with employees, so that they better understand that this could also play a role if they're in a hazardous noise area. Other things that very military specific, various different fuels, specifically jet fuel, JPA, JP8, which are all typically kerosene based. Most of those are 100%, if not 99.95% kerosene. Those have also been illustrated to have ototoxic effects when exposed for a duration of time. If you could move on to the next slide. So again, re-emphasizing ototoxic damage, it predominantly occurs and causes sensorineural damage. So again, it's that sensory pathway in the inner ear that connects the cochlea to the brain, so that the way that its sound is interpreted on that electrical impulse scale. Ototoxins typically target the middle and inner ear, not so much the outer ear, unless it's possibly due to a fetal development issue, which that's an entirely different issue altogether as far as potential pregnancy exposure or neonatal. Various different examples, again, going into how ototoxins could be able to affect workers on a micro scale. Various different solvents, like we had gone through, typically target the cochlea in the hair cells. Benzene, we'd already spoken to this. has been shown, studies have found that it targets this activation of the stapedius muscle, and that it's not able to activate that middle ear reflex. Therefore, it can be able to cause an additive or even synergistic effect when it's combined with hazardous noise. Carbon monoxide, very, very common asphyxiant, not a good thing anyway. Actually, has been shown that the overpresence of carbon monoxide within the body also affects the cochlea and the hair cells, specifically the release of glutamate in the synapses of the inner ear cells. It's not able to activate as well over time. It also has been shown to, or it also suggests that common understanding that carbon monoxide limits the amount of oxygen intake into the body just due to the overcrowding of hemoglobin, that itself may play an inherent role as to the slow decay and dying of these hair cells within the inner ear as a localized blood supply is reduced. Then continuing on, cadmium, mercury, and lead. The interesting thing about these, a lot of these are suspected. Cadmium, I believe, is a confirmed heavy metal that causes ototoxic effects. The targets, really inconclusive. We've seen a lot of different studies have an association with this as far as the presence of these and an increased presence of hearing loss with and without noise exposure. But a very interesting theory that I had seen that has a lot of merit to it actually has to do with that wonderful looking gentleman right there on the left. Right there, and if you're not aware, Ludwig van Beethoven. So Ludwig van Beethoven, if again you're not very aware, very, very famous composer. One of his predominant features as well, not only his gift for music, was that he started developing hearing loss at a very early age. And then it complete hearing loss by the time that he had passed away. One of the interesting things is that during his autopsy, it had shown that he had suffered from a shrunken auditory nerve. And one of the other interesting factoids during that autopsy is that it demonstrated extremely high elevated levels of lead that were within his body. We know now that lead has a potential of an ototoxic effect within the body, and these things kind of are checking out, especially during that time. Lead contaminated wine was very not popular, that's the wrong word, but was proliferate. It was everywhere. And him being an avid partaker of wine and drinker, some things kind of add up in a potential early example of an ototoxic effect. But I digress. So that very last point just drives home again that DOD study that combined with noise, it was lead, cadmium, arsenic, toluene, and xylene were the 5 specific ototoxins that were evaluated during that study. Exposure to those ototoxins without the presence of hazardous noise, so noise not above 85 decibels, demonstrated a higher permanent threshold shift rate whenever just at that action level for those chemicals compared to any reference group that was also present. If you could go to the next slide. Now with that background kind of history, and I apologize if it was long-winded, I wanted to be able to go into a little bit of what the Air Force is doing. It's taking a 3-step approach whenever it comes to ototoxins. Specifically, my base, how the DOD typically operates is when it comes out with new ideas, it issues very general orders. You will do this, but it never says how. It's very frustrating, but it's okay. They allow us the wiggle room to figure things out until things can get finalized. We've developed a 3-step approach, or really 3 phases whenever it comes to this first initial look at it: an identification, evaluation, and control phase. So identification, it's caused us and the rest of my 32 man team to conduct an intensive audit of every shop's safety data sheets to be able to understand and connect where are these possible ototoxins and make sure that that's connected within our database so that we can continually watch these individuals that may or may not currently be on hearing conservation. That's important for a little bit later. Evaluation. We've seen several several recommendations, not only within the DoD, but ACGIH, AIHA, and as well the European Union that suggest that a good target level or a good watch level for ototoxins and their potential ototoxic effect has to do with both airborne exposure that is greater than the action level or 50% of the OEL, and whenever there is significant dermal exposure. Just like how OSHA operates, significant is very vague, whether on purpose or not. We interpret that as a very high frequency or duration of exposure. We as well take professional judgment liberty in being able to better estimate on a case-by-case basis what is considered significant as far as potentially the use of tools. A really great example is we have processes where individuals have to wipe down the side of an aircraft to be able to clean it for future operations. One of the biggest things is they clean it with a 50-50 acetone MEK, so methylethyl ketone solution, just as a good general solvent to wipe away anything that might be present. Some of these individuals utilize a brush system to dip it into a bucket and then apply it onto the area. Some of these areas are too tight or even too broad that a brush is not very feasible. They have to don on appropriate gloves to then grab a rag and then hand apply it onto it. And so we don't take into account PPE, very similar to how OSHA typically interprets a lot of their standards or regulatory standards or monitoring that they require us to. And so those individuals that perform that process, as MEK is a suspected ototoxin, we are looking specifically at them on what their dermal exposure is. And for that example, we declare they have a very significant potential at a dermal exposure. So now we go into the control phase. We know that they're in an accurate or the best glove that we can give them for that process at the time. And after we focus on PPE, now it comes into hearing conservation. Our criteria are those very same two illustrated above during the evaluation. If they're above 50% of the OEL in an airborne exposure or have significant dermal exposure, we enroll them into a hearing conservation program, regardless of if there is noise present within their workplace. Actually, most often, these individuals do not currently have a presence within any hazardous noise area. And so one of the biggest factors with that is currently our audiology team, which only consists of about 2 audiologists. They service roughly about 6,000 to 6,200 individuals every single year in conducting annual audiograms. By our estimates on what we've currently evaluated on identifying within safety data sheets what we're going to be and who we're going to be enrolling into hearing conservation due to this focus, we're expecting that to double in the next few years. So roughly about 12,000 individuals on this hearing conservation program. But again, to better track and understand this during this time of uncertainty of we don't know truly where to take this. In addition to this, it's forced us that we've had to reevaluate almost every tool to be able to assist us within our professional judgment. If you could go on to the next slide. One of the very unique features is that the military possesses a very unique population, not only in our customers who we're serving, performing that work, but within our clientele. When I have 32 people on my team within my organization, it is not 32 professional CIHs that are there. In fact, we only have 2 CIHs. But our office consists of about 60-40. 40% are civilians who typically come from a military background. The rest are military members. And because we are a depot base, the Air Force sees that as the perfect opportunity to then send us brand new airmen. So of that 60% of our office, a majority of them are between the ages of 18 and 21. And they have been forced into, you are now industrial hygienists, go figure it out. And so it's a very interesting thing. The more tools we can develop to make that professional judgment easier on them, the more accurate our information is. And if you know anything about industrial hygiene, we rely on very uncertain data collected by very questionable means, not questionable means, questionable experiences and individuals to then make these professional judgments on. So it's something that we got to try to make as easy as possible and as well as uniform as possible. This slide just illustrates some of the tools that we utilize to be able to consistently be looking at ototoxins as well as other hazards that are within the workplace. We utilize routine assessments, special assessments, and incident investigations. Routine assessments, this is either a yearly or a biannual assessment where we go through every single shop and look at top to bottom, what are you doing to make sure that we understand it inside and out, as far as every process, every hazards that's there. We have a checklist that we go through and also to assist our brand new airmen so that they can be able to help remind some of these things to be able to look for and that are important. We also utilize special assessments. These are the things outside of that routine assessment that may be looking more specifically into individual processes or individual tasks, specifically very specific analytes. We usually do specific noise source surveys and noise dosimetry, but now it's also understanding that whenever we're performing a noise dosimetry or a noise source survey, that we're also looking at chemicals that they're utilizing during that process and during that time. Makes it so that it's a lot more time intensive, however, hopefully a better product for the customer at the end. As well as, unfortunately, whenever incidents do occur or medical evaluations do suggest that a possible exposure did happen, it then demands us that we conduct an investigation. During these investigations, it's able to help us try to fill in the gaps and further look for vulnerabilities that may be present within hearing loss cases specifically. As we're continually adding individuals that are not exposed to hazardous noise, we're looking at what chemicals they're now being exposed to that may have contributed to that hearing loss case, as observed by our audiologists. If you could go on to the next slide. That gives kind of a overall general view of how the Air Force is currently tackling the issues of ototoxins. A lot of it, again, is in this infancy where we're trying and we're trialing out a lot of different things, but the nice thing about it is that it's forced us that we have to start from ground zero and redefine these shops. The shops that I'm looking at, that base has been around since 1940. Some of these processes have not changed since 1940, but I guarantee on the major scale they haven't changed, but on the smaller scale they have. This gives us a wonderful opportunity to reevaluate it with fresh eyes and to look at this opportunity. So I love this opportunity that we have. Although it be, I wish, under better circumstances. I wanted to go a little bit more into a system known as the Individual Longitudinal Exposure Record, or ILER, that is a very unique perspective and tool that the Department of Defense has to be able to track workplace exposures during my last few minutes here. So again, I wanted to illustrate the military has a very unique population. As it currently stands in 2020, or 2022 rather, there are 1.3 million active duty military personnel. Again, these are all branches, all active duty, currently serving as it presently states, not even those who are considered veterans who are out of that active duty phase. In addition, the Department of Defense hires and is currently holds 700,000 civilian employees within the DoD. That suggests there are 2 million individuals that the DoD is taking responsibility of their health and safety for. And that means that it is now my job to better understand the entire scope of all of the different hazards and processes that these individuals are involved with for the overall national security of the United States. It's a hefty feat, but it's a very worthwhile feat. But it demands that the military has a better understanding of their process and how they want to go about this to use its time efficiently, but to make sure that these individuals are being covered. Again, a base is like a city with an extended mission. Although it needs to perform, for example, hill depot maintenance, depot level maintenance, it also has its own internal functions. It has a grocery store, it has pesticide controller, it has a golf course, for heaven's sakes. It's got schools, it's got its own police force that is present. There's various different smaller entities that make up a base rather than just the maintenance side of it. then these are all factors to be able to consider as far as other occupational exposures that an industrial hygienist is related to the military has to be able to understand. It's very multifaceted. And if you're thinking I'm putting a plug in for potentially working for the DoD, I absolutely am. But another very unique population perspective is how long are individuals that work, whether active duty or civilian, work within the Department of Defense. Many veterans, I couldn't find an exact number, but anecdotally, anytime I go survey, a large majority of the individuals that are out there that I survey were previous active duty and have now switched to civilian service. That means that potentially the DoD has the possibility of needing to track almost 50 total years of service and health and safety exposures for each and every single individual. That is a very, very big feat, and is something that you might not commonly find in some other private industry careers. I feel especially where we're going nowadays with a lot of, anecdotally, of course, with a lot of, as far as work culture, we're finding a lot more turnover whenever it comes to jobs where people are not staying typically for a long time within a single company. The DoD is not seeing that. We're seeing individuals who are staying throughout their entire working career and their entire life. And that is all something that the DoD has to now track and keep a hold of, as that's very important in the off chance, or not off chance, the unfortunate chance that they're needing compensation. You can move on to the next slide. Further addressing this and why EILR is also very important is compensation claims. Veteran Affairs compensation claims need two things. They need a current physical or mental disability, and they need an event, injury, or illness that happened while you were serving in the military to cause a disability. Now, if you're very familiar with the VA only deals with veterans. So that's not even the backside of the civilian force that also could potentially have exposures. So that civilian force is not even included in these numbers here. So you can see how it would further exacerbate it. In 2022, the VA processed nearly 1.7 million compensation claims. That is a very large amount. As a whole grand scheme of the United States, maybe not, but for one specific organization, that is more than the current members that are even present within the organization itself. With these 1.7 million compensation claims, there was a 35% success rate. That means individuals received compensation for their injury, illness, or event. The most common claims being hearing impairment, hearing loss, mental health, and musculoskeletal disorders. Two of the top three items are things that I, as an industrial hygienist, need to be tracking and actively be looking to control. We don't have too much of a focus on mental health, but maybe in the future with total worker health advancements, that expansion, who knows? I would love it, but who knows? Either way, if you could go on into the next slide. So there's definitely a need whenever it comes to these compensation claims. There's a 35% success rate. That could mean either only 35% of that 35%, those were the only valid claims, which I find very doubtful. I could also see those were the only claims that could be backed up by current data. Our database that we're utilizing is not very old. And this EILR, it was approved back in 2013, but it's not scheduled to reach full operating capacity until September of this year. So as far as tracking workplace exposures, we've done a decent job so far, but there's still some gaps that have been identified or that we want to make sure are controlled whenever it comes to tracking health and safety exposure. Yes, Dr. Whitehead, DOORS. DOORS is our database. If you've ever had any familiarity with, or I guess the downside of interacting with DOORS, it is very convoluted, but it's very thorough in trying to better understand occupational health exposures within every single base within the entire world, related to the DoD, of course. So the individual longitudinal exposure record, EILR, was developed to be able to focus, track, record, assess every environmental and occupational exposure that could happen while an individual is employed by the DoD, whether civilian or active duty. It links all of those hazards and to individuals within similar exposure groups. It uses that SEG functionality to better understand and group where are these hazards present, and that follows them throughout the rest of their career. This ILR, or this medical record, a very intensive file that whenever an individual retires from the government or leaves the government workforce, it lists absolutely everywhere they've worked, absolutely everything they've interacted with, absolutely every hazard, every association, every medical encounter, every testing, every lab, every eval, everything, in a way so that it can be able to better assist them during the potential compensation claims. It can help be that proof or denial of those claims itself, and being able to help better judge claims that are valid, saving the individual money, saving the United States government money, and as well as allowing us to have a focused attention on worker health and safety. If you could move to the next slide. I apologize. I'll go through these last two slides very quickly. Some shortfalls and demands of ILR. One of the biggest things is maintaining a competent and trained staff. Again, half of my staff, they're between the ages of 18 and 21. They could care less about industrial hygiene, some of them, especially because they didn't choose this career. They're being forced to do this, and it is very common throughout the DoD. So that constant training, that constant coaching, and helping them better understand what these are is a constant struggle. Same thing, ILR is only as accurate as the data collected. It requires a lot of professional judgment on us as industrial hygienists, but it requires us to really know our stuff whenever going into it. As well as, because of the Department of Defense, how things are authorized for us to be able to use, there's a lot of antiquated systems, assessment types, and tools that we have to rely on our professional judgment a lot. We're not able to always have the best and shiniest gadget that happens to come out of AIHA Connect, which is very unfortunate. If you could move on to the next slide. Although there are these shortfalls, and although it's been a little bit, it hasn't come into full force yet, I've been treating it as that it has. Anytime I talk to my team, I try to help them to gain an ILR mindset. And this is what I think is the most beneficial, not only for the DoD, but personnel outside of the DoD, private industry, just private contractors or consultants that are industrial hygienists. It's maintaining this framework of two things. ILR is a tool to obtain accurate and the most reliable data, but it is also a driving force. If we come to our employer and state that ILR is something that needs to be as accurate as possible, it can be able to better persuade stakeholder buy-in and employee participation. One of the best things that, or the best tools that I have to be able to help workers while I'm sampling them to feel like they're participating, or feel that this is not just me with a pump doing a study, but is something actively for them, is being able to tell them this is going on your medical record. This is going to make sure that in the future, heaven forbid something happens, you get the compensation you deserve. We're keeping the government liable and accountable for everything they're requiring you to do. And that's been something that has increased our employee participation. We get them calling us when there's an issue rather than us finding out that there's an issue present. It helps us to draw on the ultimate focus and importance of industrial hygiene, which is to help center us around improving worker health. Again, it brings purpose. It allows a perspective scope. This is a tool I've been trying to help my team understand, is that having an ILR mindset, having an overall mindset that the work you're doing today is designed to help them today, but they may not realize all that work you put in until 50 years from now, but they are going to be so grateful that you did. And so it's an integrity issue, and it's something that right now, being the best that you can be as an industrial hygienist and being as thorough as you can is something that in the long run is going to help. And ILR, that concept has been able to help us to better train our individuals and allow them to focus forward. That's really it. If you could go on to the next slide. Thank you so much, everyone, for your time. That was my overall intention. I am currently the noise program manager, hazardous noise program manager for my base. I oversee roughly about 12,000 individuals who are exposed to potentially hazardous noise. So this was a very selfish endeavor that it forced me to have to look more into ototoxin. So I appreciate you being part of it. I would like to open it up if anyone has any questions, or if you have any questions offline, my email's right there. Feel free to reach out. But if anyone has any questions, I'll be more than happy to answer.
Thank you, Alex, for that presentation. And if anyone has any questions, please put it in the chat.
Let me go verbal for a second and just tell Alex, I think that was great. I hadn't heard of Eilers. I think that's a magnificent attempt to get that going. And you presented it very well. I would like to note that Alex also presented in, some of you may know of it, the Workplace Workers Without Borders program run by Marianne Lewitsky on interpreting dosimetry. And there were people online in that presentation, Lord knows, from 20 countries, most of which in Africa and Asia. So I want to congratulate him for that. Okay, I'll shut up and it can be chat.
Okay, Alex, there's a question from Bill Young. He says, maintenance personnel at the United States Air Force flight training locations have a lot of intermittent, very high noise issues when jet planes take off or go to the hangar. How is noise not a problem in the maintenance locations you describe?
Thank you for that question. Well, I'm sorry if I insinuated that it wasn't. It absolutely is. Noise is a very big concern for us, especially due to flight line exposure, various different maintenance protocols, flight tests specifically, where individuals have to be directly next to aircrafts running functional checks. That's where previously, whenever I had mentioned that we have roughly about 6,000 personnel that are currently on the hearing conservation plan, that is only due, or they are solely on that hearing conservation plan due to noise exposure alone. So far, we've only implemented probably included only about maybe 100 or 200 individuals onto that plan that are only ototoxic specific, but we're expecting a little bit more. But absolutely, noise is a tremendous problem in the maintenance locations that we described. But we've also been trying to do a lot better understanding of ambient noise, as one of the things we've identified is that just because an individual is on the flight line does not mean he's being overexposed to noise. And we've done extensive studies looking at that ambient adjacent work that might be happening on a flight line that may not actually be impacting the individuals within the hangar. So the impactful noise is different than the perceived noise that they're experiencing.
Thank you from Bill Young. Oh, yes, we do have from Dr. Whitehead. Are hydraulic fluids ingredients autotoxic?
Ultimately it's the golden answer. It depends. No, I believe some of the hydraulic fluids that we've investigated and looked at, some of them do contain trace amounts of some other solvents, such as xylene or toluene, and those ones, then yes, they could be considered that. As far as a general overscope of hydraulic fluids, I have seen some studies that do suggest hydraulic fluids in nature, or I guess naturally do suggest they have ototoxic effects, but I think it really just comes down to the very specific ingredients that are in it, and comparing that to some of the lists that are out there. Again, there are hundreds, if not thousands, of chemicals that have been shown to possibly have ototoxic effects, so I would not doubt it.
Thank you, Alex. We will take a short break. Please be back by 10:55 for our final presenter, Jorge Gomez, who is a compliance assistant specialist with OSHA. Welcome back, everybody. I hope you enjoyed your short break. We will get started on our final presenter. Jorge Gomez is employed by the U.S. Department of Labor with the OSHA department. He has been employed for 11 years, 8 of those as an enforcement officer, and now serves as a compliance assistant specialist. As a compliance assistant specialist, duties are to provide general information about OSHA's compliance assistance resources and how to comply with OSHA standards. So please welcome Jorge Gomez.
Hi, everyone, and thank you, Serena. I apologize that I'm not sharing my video, but earlier when I was testing it out, it was giving me connection problems. I promise I'm not trying to hide who I am. But yeah, so thank you for this opportunity, this time to speak to you all. We definitely do appreciate the opportunity. In presenting this information to you all, I wanted to get a little bit more back to the basics and cover some of the some information that hopefully you all have in the front of your minds whenever you are looking at chemical safety in the workplace. And with that, let's get going. So a quick disclaimer. Federal agencies, we always got to include some sort of disclaimer, right? And the disclaimer here is saying that all the information that I'm going to present and speak to you about is information that ultimately is publicly available to everyone. I gathered this information myself to present to you, and again, it's all publicly available. If I present some information that I may present information that at the moment may not be publicly available just because I have direct access to our systems, but eventually everything becomes publicly available. And if you see anything with my presentation and you'd like more information on that specific bullet or topic, please reach out and I'll get that information to you. So this is what I'm going to be covering during my presentation. I always like to cover some OSHA basics, what our local OSHA offices are, what they do for workplaces. I'll cover some general local statistics, go on to workplace chemical safety and the OSHA regulations, and of course, I'll leave you with some resources that hopefully you can use. Okay, so again, the compliance assistant specialist for the Houston South area office. We have 2 offices in what we call the Houston area, and these are our jurisdictions. The Houston North area office is located up in Conroe, and the Houston South area office, which again I'm out of, we're down in Clear Lake near NASA. The area director for the Houston North area office is Mr. McKeewa Hager. They also have a compliance assistant specialist up there, Jim Shelton. And my boss, my area director, is Mr. Mark Briggs. And again, I'm the compliance assistant specialist for our office. In total, in case we have people from outside of the area, which I'm sure we probably do, in total, there are 9 area offices in Texas. And this is what we do out of our offices. First and foremost, we do inspections, we do investigations. We are an enforcement agency. The laws and regulations in the 29 CFR are just that, laws. They are not suggestions, they need to be followed. But we do also offer compliance assistance, and that's where, again, folks like me come in. In the compliance assistance room, if you have a question regarding any regulation, any action that OSHA may take, you can always reach out to us, and that's our main job to answer those questions, answer those calls, whether it be from employers, from employees. We're there to assist with compliance with the regulations and do outreach. That's another realm that falls under the realm of the compliance assistance specialist outreach, which is what I'm doing here with you guys. I'm also currently at an expo, so we'll set up exhibit tables, talk to people out in the industry as well. The training that we do, we mainly do that through our grant program called Susan Harwood Training Grants. Every year the agency awards, I've seen it anywhere from $10 to $20 million in any given year for nonprofit organizations to develop safety-related training on any number of set topics. That those set topics are selected every year. And then the goal is that once that training is developed, it becomes free to industry and the community. Penalty collection, I like to keep that in there because, again, we're an enforcement agency. If we issue citations, if we issue violations, those come with financial penalties, at least for the private sector. If there's anybody here in the public sector, reminder that OSHA has no jurisdiction over state employees, state local government employees. In our jurisdiction within the Department of Defense, those branches is also somewhat limited, although we do have MOUs with DOD and the different branches as to where they will adhere to or follow OSHA regulations. Really, we wouldn't be doing an inspection because the service member got hurt. We would come in more where contractors, where the civil service, the civilians that work for those entities, those branches may get hurt. That's where we may come in. But we do collect those penalties. We don't keep any of that money. That's all we do. We collect that money, we send it to the treasury. Abatement assurance is where we are required to go back out and re-inspect a certain number of inspections, investigations that we conducted to verify that the violations, the problems that we found during inspections, investigations were actually corrected. If we find that they haven't, then it's another investigation, and then the penalties multiply by a lot. Those are the basic functions of every area office that you'll find here in Texas and throughout federal OSHA. Okay, so why are we? OSHA's mission and continuing mission. Back in 1970, when the OSHA Act was signed into law, and go back that far and talk about that, we were losing about 38 workers a day. That translates to roughly 14,000 people. In 2021, which is the latest numbers from BLS, that has dropped down to approximately 14 a day. That's still a lot of workers. But progress has been made. And like that first bullet says, OSHA and its partners. These partnerships, this outreach that we do, like we're doing here today with you, is very important to us because in the grand scheme of things, we are a very small enforcement agency. There's millions of workplaces out there in the nation, and we are a very small agency to be able to cover all of those workplaces. So we need to rely on partnerships with industry to get these numbers down. And we've done a great job, but we need to keep going. And really, I always like to point out that number 38 from back in 1970, I'm not sure how much stock I would put into that number because really we don't know. Before OSHA came along and its regulations, its record-keeping regulations, there was no requirement for employers to report. There was no requirement for employers to keep track of fatalities, workplace injuries. So we really don't know. I know in one of my when I was still in school, I tried to do some research into that and see if I could come up with a better number, more accurate number, because I felt like that number was slow. That 38 is slow, and there's really no good data out there. I mean, I've seen some estimates go as high as 60, 80,000 a year. So the range is really all over the place, but that we're able to promote that 38 number, that's another probably indicator that it's on the low end. The work-related injury and illnesses, those have come down a lot too, from 10.9 incidents per 100 workers, which really translates to about 10 million incidents a year, to down to around 2.7 in 2021 also as well. Well, actually, no, that 2.7 is in 2020. The 2021 number is 2.6. So it has gone down. However, if you go back throughout the years, that's normally where we hover between 2.8, 2.9 to about 2.7, 2.6. So there's still a lot more work to be done there. And that's where in those injuries and illnesses is where a lot of the problems that we see with chemical exposures lie. A lot of folks that are exposed to chemicals in the workplace, they don't develop symptoms. They don't develop an illness until years later. It's, the same problem like the previous speaker was talking about hearing protection, hearing conservation. It's estimated millions of people are impacted by workplace hearing loss. However, we're not really able to track that accurately because, again, people aren't affected for years until years down the line. And they may have worked 5-10 years in a certain industry where they were exposed to high noises. And it wasn't a problem until later on in life. So there's a lot of cases like that we know are out there, especially, again, when it comes to hearing conservation. And that's the same problem with people being exposed to chemicals in the workplace. All right, so that national fatality snapshot, how many folks are that 14 a day? This is what it looks like distributed across the country. The two numbers there, if you look at specifically at Texas, where it's 469 and /533, 469 is the number from 2020. 533 is the number from 2021, which again, we get these numbers from the Bureau of Labor Statistics. And they publish those every year around the second or third week of December. So the latest numbers are still from 2021. This year, we'll get the numbers for 2022. The states that are starred with a star, that's OSHA Region 6, which is New Mexico, Texas, Oklahoma, Arkansas, Louisiana. That's the region that I work for. That's the region that we cover. New Mexico is a state plant. So in New Mexico, federal OSHA only covers federal sites. So 2021, that 14 a day translated to 5,190 deaths, which is an 8.9% increase from 2020. Pretty high. If you just looked at 8.9%, normally the fluctuations is more in the 1 to 2% plus or minus. However, to me, that's an outlier year because we all know what happened in 2020. That was the start of COVID, shutdowns and lockdowns, work diminished. So we had a huge drop in workplace fatalities for 2020. That year we recorded 4,764, which had been the lowest number since 2013. But again, that's an outlier due to COVID. Construction is one of our main focuses because that's where we see a lot of the problems. That's where we see a lot of chemical exposures, people being exposed to chemicals without protections. And also that's where we see the most fatalities. For a single industry to account for 951 deaths, compared to everyone else, transportation, mining operations, that's a lot for just one industry. And that's where we have national emphasis programs, local emphasis, regional emphasis programs to where we try and target construction workplaces to ensure that they're adhering to the regulations. All right, so Texas role in the national fatality snapshot. We're the most fatal state to work in, and we've been it for the last 13 straight years. So far, the numbers that I see for this fiscal year, which is going to end on September 30th, we're tracking to meet our averages, which would still probably put us in the top will still make us the most fatal state to work in the nation. We took that title from Texas, from California, 13 years ago. For a number of years there, we would go back and forth. They would lose more people one year, we'd lose more people the next. But 13 years ago, we took it and we've just run with it. I always like to highlight this because we need to do better. We can't be the most fatal state to work in. Texans, we always like to brag that we're bigger and better than everybody else. Well, let's not be bigger and better at losing our folks on the job, because we don't have the largest workforce. Some of the comments most comments that I get back when I say this is that, well, we're continental U.S., largest state, lots of oil and gas, lots of construction, lots of industry. Does it kind of come with the territory? And again, if we compare it to California, where there used to be the state who lost the most people. No, they on average, if you look at again the BLS data on the workforce, on average, California has 4 to 5 million more people in their workforce than Texas does. When I've looked into it, the only industry that was larger here in Texas than in California was the oil and gas industry, and even then, it was not by a lot. It was a difference of 1 to 200,000 individuals within that workforce, because California too has a very large oil and gas industry. So I always like to include this in there because, again, it's not going to be OSHA who's going to get us out of this number one spot or most fatal state to work in. It's going to be you folks working out in industry that see those workers on a daily basis and are tasked with protecting those workers. Here locally in the Houston area or southeast Texas, which again encompasses the jurisdictions of the Houston North and Houston South area offices, we fluctuate between 45 and 55 employees that we lose a year. Now, this is only workplace-related fatalities that OSHA has jurisdiction over that we end up investigating. That's not the total number of how many people are actually dying here locally, because on average, we receive between 160 and 180 reports of workplace fatalities. How we end up with that 55 number is that a chunk of it is transportation. That normally counts for about 40%. That's covered by DOT. That's not OSHA. So we don't have jurisdiction there. Other areas where we might not have jurisdiction, a big portion of it too is that of that 160, 180, 70 to 80 fatalities that normally get reported to us on any given year, we classify those as natural cause deaths or medical events. What does that mean? That means that somebody's found unresponsive on the job, somebody collapses, they're given medical attention, they pass away. The coroner, the MEs make a determination that the cause of death was due to a heart attack, was due to some sort of other medical condition. They had an aneurysm, they had a seizure. However, though, we can't forget that, yes, you have to have a medical condition for you to suffer that medical event, but there's also has to be normally a trigger that makes it happen. And I bring that up because you've all been hearing hopefully about heat. It's really hot out there. Here in the Houston area, we're talking about 110, 112, 111, even at 7 p.m., 8 p.m. still. And if we're talking about those workers, specifically in construction in the chemical plants that are working outside in direct sunlight, then you even add another 10, 15 degrees to that because they're in that direct sunlight. So with health, that's a big push for us right now. We're trying to come up with regulations to formally address it. However, it's going to be tough because us trying to come up with a heat standard is not new. We've been trying to do this since 1972, and really OSHA opened its doors in April of 1971. So one of the first things that we tried to do was address heat hazards. We haven't been successful, but we're going to keep trying, and hopefully we get there. So with those, like I mentioned, outside of those fatalities, we have other things that happen. Serious incidents events, what we call an SIR. This is where an employee suffers some sort of injury, some sort of illness, where they have to be taken to the hospital, admitted for treatment. That's what falls into a serious incident event, which hopefully everybody knows that fatalities need to be reported to us within 8 hours. And outside of that, a workplace injury that requires that employee to be hospitalized, need for treatment, needs to be reported to us within 24 hours. Amputations need to be reported to us within 24 hours, and loss of an eye need to be reported to us within 24 hours. So this is where those serious incident reports come from. Any number of these could have been a fatality. If you break these down, a lot of it just comes down to luck, luck of the draw. So as you can see, our offices are very busy, very busy. Between the fatalities that we need to investigate and the serious incident reports, we're very busy, and that's why, again, we need your help out there when you're managing, administering your programs. Please make sure that they're being properly enforced. If you need resources, if you need more information, reach out. We're there to help you. We're not just there to come out and do inspections and issue citations. All right, so what we're here for, chemical safety. And my goal here is not to blow your mind with any new information. It's hopefully you've already heard what I'm going to say, and if not, please realize some of this information that I'm gonna share with you, and keep it in the front of your programs when you're developing your programs, when you're developing your sampling strategies, to better be able to protect your folks. So permissible exposure limits, PELs, PLs, occupational exposure limits. That's what we enforce, right? And we do it through tables C1 to C3. C1 and 2 contain permissible exposure limits for air contaminants, fumes, dust. Table C3 is concentrated to just mineral dusts. If you go to those tables on our website, www.osha.gov, by the way, if you go to, and I see questions coming through, unfortunately, I'll wait till the end to address them. We have notes in those tables when you go to them. Please read these notes and pay attention, because like this, every one of our tables, E-tables, will say this table only includes occupational exposure limits for substances listed in the OSHA C table. OELs for hundreds of additional substances have been adopted by Cal-OSHA, NIOS, and ACGIH. These organizations periodically make revisions to their OELs, and so they should be consulted directly for their most current values and substances, as well as special notations such as for skin absorption. That note is very important, because then we come to this. And I'm not the type of person to read directly a slide, but I need to. OSHA recognizes that many of its permissible exposure limits are outdated and inadequate for ensuring protection of worker health. Most of OSHA's PELs were issued shortly after adoption of the Occupational Safety and Health Act in 1970 and have not been updated since that time. Section 6A of the OSHA Act granted the agency the authority to adopt existing federal standards and national consensus standards as enforceable OSHA standards. Most of the PELs contained in the C tables were adopted from the Walsh-Healy Public Contracts Act and existing federal contracts for general industry. These in turn had been adopted from the 1968 threshold limit values of the American Conference of Governmental Industrial Hygienists, ACGIH. Some consistent standards from American Standard Association were also adopted at that time following the 6A procedure. Comparable PELs were adopted for shipyard and construction. So if you work in shipyards, for my Department of Defense brethren, any Navy folks out there, if you work in shipyards, there are specific PELs for shipyard and construction. There is some differences. So please go look at those specifically and don't just say, well, I'll just follow general industry. There are some differences. So what was that section 6A? What did that specifically do or say? So that said that we had a period of 2 years to identify these already existing consensus standards and make them law, basically. We had 2 years to do that. We can't go back and redo that. If we want to come up with any new regulations, then we need to follow the procedures in section 6B, which requires a lot of steps and a lot more information that we need to do to be able to prevail and actually add chemical substances or amend those PELs. That's why it's been so difficult. So yes, OSHA PELs remain in effect. That's what OSHA can enforce. That's what we enforce. However, we recommend that employers consider using the alternative occupational exposure limits because the agency believes that exposures above some of these alternative occupational exposure limits may be hazardous to workers, even when exposure levels are in compliance with the relevant PELs, which is the OSHA PELs. This is in my language. This is language taken directly from our website. When you go to those OSHA C tables, we're telling you this up front. And if you go to those tables, that this is what it looks like. Cal OSHA works on PELs just like we do. Only Cal OSHA can enforce those PELs. Outside of that, for us, again, they're just a recommendation. NIOSH is the recommended exposure levels, and again, the ACGIH is the TLVs and the BEIs. That's a screen grab of what that this right here is the Z2 table, because I mentioned going back to the Z1, and just by seeing some of the chemicals that are listed in there, this is the Z2 table. So we give you a comparison. Some of the times, probably 60 to 70% of the time, there might not be a difference. And I say that 60, 70% because years ago, I actually went through all this and tried to identify where there were differences between Cal OSHA, NIOSH, and ACGIH and OSHA. And it turned out about 60% of the PELs actually matched across the board. But there is some differences. If you look at that last one there, carbon disulfide, our 8-hour TWA is 20 ppm. Cal OSHA is 1 ppm with a short-term exposure limit of 12 and a ceiling of 30. Our ceiling is 30 with an acceptable maximum peak of 100. So there is some differences out there. That's why we say that there's more updated information out there. And if you're able to follow it, then follow it. So by no means am I trying to put down the agency that I work for, but it's just realities. And we have tried to update the PEL information. Since 1970s, we've updated or came up with 16 new PELs. However, that's just 16. And we came up with standards without PELs for 13 carcinogens. I didn't list those 16 PELs because those have just been absorbed into the Z tables. But the list of the 13 carcinogens, well, that's it. There's no PEL for those carcinogens because it's either a known or suspected human carcinogen, and there's really no amount that we can say, well, a person can be exposed to this amount without getting cancer, because we're all different physiologically. I could be exposed to a certain amount and be okay. The person next to me can be exposed to half that amount and not be okay. So for that reason, there is no pill for those carcinogens if anybody works in those type of environments. There's regulations that you need to follow to make sure that nobody's exposed at any level. I also made it a point to leave the CAS numbers in here, because chemical synonyms, man, it's a lot of the times it's better to work with CAS numbers. I learned that lesson before I came to OSHA. I worked in the hazardous waste management industry, and trying to classify hazardous materials and dealing with all the chemical synonyms. You read something like, oh, this doesn't sound that bad. And then you cross-reference the CAS number and you realize, oh man, this is something really bad. At least back in those years when I was dealing with a lot of MSDS back then information and looking at these chemical names and dealing with their synonyms, it almost seemed like chemical, the person developing that MSDS would purposely find the chemical name synonym which seemed the least dangerous, the least hazardous. So I always like to work in CAS numbers when I'm dealing with chemical names. All right. So again, what else have we done? Well, in 1989, we had a big push to try to update some of these PELs. In total, we have just over 470 PELs, and back in 1989, we tried to update 212 of those and add another 164. They came out one day. We released the updated PELs one day. We got sued very quickly, which then they stayed. And we lost the court case in 1992, which said no, which the 11th Circuit's court basically said, no, OSHA, you didn't follow proper regulatory procedure for trying to do this, so no, you can't do it. Go back to the original for those PELs, for those 212, and you have to delete the addition of those 164. And that's another reason why we recommend taking a look at NIOSH and Cal OSHA and HCGIH, because they have a lot more chemicals. They have TLVs, they have RELs, they have PELs for a lot more chemical substance than we do, a lot more. And also as early as 2014, and that's almost 10 years ago, but when you speak government, 2014, 10 years is not that long ago. So in 2014, we published a notice to a proposed rule making on chemical management and permissible exposure levels. And that was what we were doing there. We were reaching out to industry and say, again, hey, listen, we recognize that our information for the PELs are outdated. Let's work together, give us information on how we can best go about updating these. Unfortunately, I haven't seen anything else since then. I've checked the regulatory agenda and it's not there, which our regulatory agenda, well, the government's regulatory agenda really, which covers all of its agencies, gets published twice a year in the spring and the fall. Sometimes it's only in the spring, sometimes it's only in the fall. And then with that, it's always administration priorities also come into play, right? So we have been trying to do, this is always at the forefront, I would say, of what OSHA is trying to address and look out for. Another reason why you need to be aware of these alternate TLVs, RELs, PELs is that if we have a PEL for it within 29 CFR, then that's what we can enforce. If we don't, then we can look at consensus standards and try to enforce those TLVs or RELs through what we call the Section 5A1 of the OSHA Act. A lot of folks, especially safety folks, know that or think of that as OSHA's catch-all. That is by far what it is, because it is not easy for us to work to issue citations under 5A1. The burden of proof for us there is a lot higher than if we had an actual standard to enforce. So we don't make wide use of that 5A1 like people out there would like to think, actually. But please be aware that that is an avenue for us to try and take if there's no Pell listed within 29 CFR. So if you're going through the Z tables and you say, oh, chemical is not listed, it's not regulated, that is not the end of it. That is not the whole story. Please go to NIOSH. Please go to ACGIH. Please go to Cal OSHA and look at those alternate OELs. All right. So now getting down to what we see locally. In FY22, which is from October 1st of last year to September 30th of this year, or of last year, we conducted 170 inspections, investigations, as what we classified as a health inspection. We break our inspections, our main inspections, into two types. It's either a safety-related inspection or a health-related inspection. So on average, depending on staffing levels, our office can do anywhere from both our offices, North and South, do anywhere from 800 to 1,200 inspections a year. If we're fully staffed, like we're close to right now, we're not fully staffed, but we're doing a lot better than we have in other years. We're doing about 1,100, 1,200 inspections. That's how many we did in FY22. So out of that 1,100, 1,200, only 170 we classified as health and inspections. Out of that, 11 were fatality investigations and 6 were serious incident reports. We issued 309 citations, and these were the most common citations that we issued under that 170 inspections. HASCOM related violations and E1, H1 were the most common of that. E1 is the requirement to have a written program on premises on site, and H1 deals with the information that is provided to employees for the chemicals found in their workplace. From that is silica. Silica has been a big push for us really since again a long time ago. Silica is one of those substances that, going back to probably the 20s, 30s, we knew could cause cancer, lung cancer. But it's only been in recent years that, from the regulatory standpoint, we've been able to revamp, come up with a silica standard and revamp that information. So 1910, 1053 is what applies to general industry, and 1926, 1153 is what applies to construction industry. Even though we have quite a bit of maritime work going on within our jurisdiction, from Galveston out to the Sabine, Port Neches area, there's a lot of maritime work going on within that region. We don't see a lot of violations within that. I'm not saying that there isn't. I'm saying that we don't inspect too many of those places for whatever reason. Because on the flip side of that, I can tell you that when we do go out there, we do find problems. For comparison, the national top 10 most cited by OSHA in fiscal year 22, where fall protection has been number one for 15 years. Hazard communication, respiratory hazard communication is always within the top 5. between 2 and 3 is where it normally fluctuates. Respiratory protection is normally within the top 10, not necessarily within the top 5 even, but again, 2020, 21, and even going into fiscal year 22, we saw respiratory protection move up because of the COVID. I included the number of violations that we see there within each of those. And yeah, hazard communication, we just see a lot of it. And it might be because when we go out and we do an inspection, there are basic things, basic elements of a safety program that or site safety management that we're always going to check. We always need to check those. One is check the OSHA 300 logs, record keeping, make sure it's being maintained and done correctly. 2 is HAZCOM programs. We need to verify HAZCOM programs. If the verification is that there's no chemical use, okay, there's no chemical use. But if there's chemical use, then show us your program and show us your training. And that's where we find a lot of the problems for you folks that are more on deal more with that realm from the IH side of the house. From my experience, a lot of the problems that I would find with HAZCOM programs, it wasn't the absence of a program because there was usually one. The problem came down to the training and the employee awareness, because when I would start asking employees, hey, have you had HAZCOM training? Well, yes, we go through, a computer CBT at least once a year. So yeah, I know that flammables, will create fires. I know that corrosives can burn your skin, toxics. So they're able to say, yes, chemicals, these hazardous chemicals present a danger to you. But then you turn around and you say, okay, within your environment, tell me what's flammable, tell me what's corrosive, tell me which of the chemicals that you use on a daily basis pose those hazards to you. And that's where the faces kind of go like, I don't know. I mean, most of the stuff here is stuff that I have in my house. So I don't think it's really a big problem. The use of consumer products in the workplace, it's fine. It's legal to do, of course, but we don't use consumer products as consumer products that are being used in the workplace. The consumer product is meant to be used at your home. You use it once a week or very short periods of times, once a day. If you're using it at work for most of your work day, that's not consumer use. You need to evaluate those exposures. You need to let those employees know about the hazards specific to those products. Don't just sit them through CBT to learn that chemicals are hazardous and what risk it poses to them. You have to tell them which chemicals within their environment actually pose those risks to them. So that's what I would find a lot of problems with hazard communication programs. Okay, so resources. Again, we offer a lot of resources. This is a screen grab from our public website, www.osha.gov. All the information that I just presented to you came from this website. And I do that, I try to do that in most of my presentations to at the end show you just the amount of information that we have out there. Hopefully you visit our website regularly. But I highlighted a couple things there that I wanted to make sure I specifically addressed to you guys. Again, compliance assistance. Every one of our offices, I can't think of one right now within our region that doesn't have a compliance assistance specialist in their office. So here in Texas, you have nine of us. Here just in the Houston area, you have 2 of us. There's 2 in Louisiana, there's 1 in Arkansas, there's 1 in Oklahoma. And again, we don't have anybody specifically for New Mexico because that's a state plan. But if you're a federal site and you need help, we have somebody in El Paso, we have somebody in Lubbock who would cover those areas from the federal standpoint. And if you click on that directory, well, if you click on that link, you'll come up with a directory with our phone numbers, with our emails. Data and statistics. All of our information is public. If you go into our data and statistics tab, you can search companies. You can search our inspections that we're doing. You can see what kind of citations we're issuing. So that's a good reference point for if you're looking to work with contractors or subcontractors. You ask them for their information. Hopefully they're honest and they keep their records properly, and it's not one of those things that we see at times where, hey, I got this contract, or I'm trying to bid for this contract, and they're asking me for my OSHA 300 logs or my TIR. Well, fill it out and give it to them, because it happens. But go and look them up in our statistics. See if they show up. See if what they're presenting you actually matches. Because if there's any inspections, they're going to be there. Small business resources, publications. If you need publications, most of our publications are now downloadable e-files. So it's there. If you need any training, down at the bottom right-hand corner, Susan Harwood training grants. Again, once that money is given out and that training is developed, that grantee has to offer it to its local community. 2, we end up with a copy of it, which then you can access through that link. And if you need a presentation on hearing conservation, if you need a presentation on HASCOM, there is a presentation out there that has been developed under that program. Most of our grantees end up being educational institutions. A lot of universities, a lot of colleges develop this training. And I'm not saying that it's going to be 100% what you need, but it's downloadable files that you can use, that you can update. So why start from zero if you have a starting point, right? And of course, call me or my colleagues, text us, email us. Our job is to be a resource out there for industry, for you, for the community. So we are there if you need us. This is my contact information. And with that, I will open it up to questions.
Thank you, Jorge, for that presentation. And if anyone with a question, just put it in the chat.
Which I saw some chats already, but let's see. Or at least I saw one.
Yes, it's from Alex, and it says, have you seen any difficulties in potential underreporting of injuries or fatalities involving underrepresented groups such as immigrant populations?
Yes, without a doubt, most definitely that is something that we are hard trying to address on a national level, because we know it's happening. It's very common, unfortunately, for us to receive calls at our office, or even me directly, from employees who are saying, hey, I got hurt at work and my employer doesn't want to pay me. That's where we end up hearing from it, unfortunately, not when it happens, not because the employee is being exposed to a hazard, but because the employer said, oh, you broke your leg? Don't worry about it. I'm going to take care of you. I'll help you with your rent. I'll help you with your food. And they might do that for a couple of weeks, for a month, and then afterwards they don't do it anymore. And then the guy finally has enough courage, because he's in a really tough spot. And he's trying to now find that help that he should have reached out to, before the incident happened. Yes, that is very common. We work with consulates. All of my colleagues here have relationships with the Mexican consulate, Salvador, Central Americas, Asian consulates. Yes, we try to reach out to all the minority communities, those represented employees within our own communities, to make sure that they know that the rights apply to everybody the same across the board, whether we're not immigration. So if you're working here in the States, then you're protected by the OSHA Act. that is a big problem for us. And yes, we have a multitude of initiatives where we try to address this. Which, by the way, Alex, I think I saw where you work for DHA. My wife also works for DHA. So that's pretty neat. But anything else, guys? How should try to clarify the company's responsibilities when TB testing is done, compliant to the SILCA standard, and or test positive. Something from scrolling down, test positive, whether benign or contagious. Is it more common for hospital workers to be tested associated with employees for abrasive? So I think if you go back and you look at the standard, without having it in front of me, I think we have been already pretty well, as clear as can be. I think we don't really see that with abrasive blasting folks at all. I want to say I can't think of any situation here locally where that's come up for blasters. Honestly, even myself, I hadn't thought about it from that angle, but now that you mention it, I'm definitely going to see if I can do some research into that. Where we do see it as more in hospitals. And again, the testing and the vaccination, that's at least from the healthcare standpoint, there's a few LOIs or letters of interpretation that try to further explain and address the requirements when it comes down to TB testing and the vaccination in healthcare. Yeah, Marianne McGee, she's a wealth of knowledge. She's a great colleague, great person to work with. She's great. Which, by the way, I guess I'll just make another little comment that I was thinking about when I was hearing the closing for the previous presenter. And we're talking about the Air Force, I believe, and their noise exposures. There was a document that, and it's been years now since I've seen it, but within that document, it basically said when dealing with chemical exposures, DoD, Army, Navy, Marine Corps, they set their order of precedence for what was their preferred PELs or what they were going to follow. And for Army, Navy, Marine Corps, it was OSHA PELs followed by ACGIH or NIOSH. But the Air Force was the only one that I recall where their order of preferred precedence for the OELs that they were going to follow was ACGIH. So good on the Air Force.
If there are no more questions, Alex says you're correct. I want to thank all of our attendees for attending, and I would especially love to thank our presenters once again for agreeing to present for our learners. We will be sending evaluation and certificates of attendance will be sent by email. Please fill those out. And for evaluation, like I said, we sent a survey out a few months ago, just trying to get your ideas for future topics and frequency of the seminar series. So if you have an idea for a topic that you feel we need to cover, please put that in evaluation. If you personally would love to present, we'd love to have you present. You can put that in the evaluation. And or if you'd like to recommend a speaker, we can also help. You can help us get in contact with future speakers. So with that, a last call for questions. A lot of people thanking our presenters in the comments. That's good. So Alex has put his contact email for anyone who needs it. And I guess with that, that will end our industrial hygiene seminar series.